Okay, so we're checking out here part B-1 of the June 2019 Chemistry Regents exam, and let's go ahead with question 31. So what we're looking at here, it says the bright line spectra for four elements, G, J, L, and M, and we're looking at a mixture of at least two of these elements. So the bright line spectrum is like a fingerprint for the different atoms of elements, right? When elements absorb energy, electrons move further away from the nucleus. When they drop back down, they give off energy in the form of light, and when that light is bent, we get these bands of light, almost like a fingerprint. So our mixture here is a mixture of both, so we need to account for all the lines in the mixture. So it's just process of elimination as we go. So for instance, can't be letter J here. We're going to go ahead and cross that one out because it's not here in our mixture. It can't be M because we're missing this first line. So we get to the line here at the mixture between 700 and 650, and that's accounted for in G. But it's not just that. You have to account for all the lines. So we have a match here with G. We have a match here with G. We don't have these two bands with G, but we have the last two. All right, so what do we have left? Well, it's got to be a mixture of G and then L. So the two bands here for L. So G and L, and sure enough, we have choice 2. Let's move on. All right, let's check out question 32. Which electron configuration represents an atom of chlorine in the excited state? So excited state means electrons are moved out from the ground state. So let's go to the periodic table. Here it is. We need to check out chlorine. Chlorine is element 17. You see the electron configuration for chlorine in the ground state, 2, 8, and 7. So we don't want that. We want one or more electrons moved further out. So let's go back to our choices, and let's just go through those right now. We know that chlorine is element 17. We saw that on the periodic table. We have to account for 17 electrons. That ain't going to be the case here in choice 1. Too many electrons. We go to choice 2. Lo and behold, it adds up to 17. But that's the ground state for chlorine. It matches what's on the periodic table. That's not the answer either. We go to choice 3, and we're dealing with 18. That gets crossed out. So the only answer here, sure enough, it adds up to 17, but we have an electron that's been moved out from the second to the third level. So that's the excited state, choice 4. 33, a student measures the mass and volume of a sample of aluminum at room temperature, calculates the density of aluminum to be 2.85 grams per cubic centimeter. Now it says based on table S, what is the percent error for the student's calculated density? Percent error, the formula for that is on reference table T, but what do we need to do? We need to go to table S to get the value, the actual value, the true value, the known value for the aluminum density, and then use that with the student value to figure out percent error. So let's just do that right now. So we need to find aluminum, and here it is. It's element 13, and we need to go over to density for aluminum, and the density is 2.70. So that is our known value, and we're going to go ahead and use that now for our percent error calculation. So here is the percent error equation, and I'm just plugging the numbers in here so you can see it. 2.85 was the measured value. That's the student value. Accepted value, we picked off a reference table S as 2.70. So you're going to take the difference of those two numbers. You're going to divide by 2.70 times 100 to get the answer. In other words, 0.185 divided by 2.70 times 100. Use your calculator and then check. And let's go back to the choices here. And here are the choices. This is where you need to be careful because a student might just say, oh, you plug it in the calculator, it's around 5, and think the answer is choice 2, but it is not. In the calculator, it's 5.55555, which rounds to 5.6, which is choice 3. So here is a classic example of the regents trying to trick you, right? A little subtle because 5.3 and 5.6 are so close. Do everything paying attention, plug in with the calculator, read the numbers off the calculator to get your answer. Again, here as choice 3. Let's go to 34. Here, magnesium and calcium have similar chemical properties because their atoms in the ground state have. Well, you want to look this up on the periodic table. Make sure you know where magnesium and calcium are. Of course, they don't give you the symbols. Periodic table only has the symbols. Reference table S. You can always double check the symbols. It's Mg and Ca. Now, you're looking at atoms in the ground state, and what do they always have? So if we go back to the periodic table, I went ahead and circled magnesium and calcium. Sure enough, they're both in group 2, and you should remember from class that all elements in the same group for groups 1 and 2 and 13 through 18 have the same number of valence electrons, those outermost electrons, which in the case of group 2 is 2. So let's go back to those choices. And sure enough, when you go through the choices, the only one that makes sense is choice 4, 2 electrons in the outermost shell. For 35, it says, as the elements in period 2, remember that's the second row of the periodic table, are considered from left to right, which property always decreases? Now, when you're dealing with periodic trends, you can look up almost every single one of these on reference table S. The only one that is on the periodic table itself is nuclear charge. Nuclear charge, right, the charge of the nucleus, you have protons and neutrons. So, of course, what has a charge in the nucleus are the number of protons. So if we take a look at the periodic table, lithium starts out period 2, and we're going all the way across. Now, atomic number is also your nuclear charge. Of course, as we're going from left to right, the nuclear charge increases. So that's not going to be our answer. We're looking for something that decreases. So of the other 4 choices, we got to go to reference table S. And what I always suggest is taking 3 elements, maybe lithium, boron, and fluorine, and looking up the numbers now for the other 4 choices on reference table S. So let's go ahead and do that. All right, let's start with first ionization energy. We're going from 520 to 800 to 1681, so that's increasing. We go to electronegativity. We're going from 1 to 2 to 4. That's increasing. For atomic radius, we're going from 130 to 84 to 60. So obviously that's decreasing, and that's our answer. So even if you think you know the answer with periodic trends, it never, ever hurts to go ahead and check it anyway. You have all the information in front of you. It's just a quick double check. So let's go back, and the answer to 35 was choice 1. All right, let's move on. In question 36, we're given a balanced equation of butane and oxygen, and we're asked, how many moles of carbon dioxide are produced? So what I always tell my students, and I would suggest, we're going to put an X above CO2 when 5 moles of butane react completely. All right, so we have these coefficients, of course, which help us balance the atoms of the different elements on the left with the atoms in the different elements on the right. So we have a coefficient of 2 in front of butane and an 8 in front of CO2. So it's a 2 to 8 ratio or a 1 to 4. In other words, I like doing it this way because now if I draw two lines and set up equal signs, I have a proportion. It's 5 over 2 is equal to x over 8. And now all we're going to do is cross multiply and divide. So what's 5 times 8? Of course, that is going to be 40. And then it's 40 is equal to 2x. And of course, I'm going to divide both sides by 2. So our answer here is 20 moles. With question 37, what is the percent composition by mass of nitrogen in the compound N2H4? And they already give you the gram final mass. You don't even have to figure it out. But we're going to need to know the mass of nitrogen. So let's go to the periodic table. With the periodic table, the mass of a nitrogen atom is 14 AMUs. So we need that information, right? It was 14, but I have two nitrogens. So I need to double that, okay? And percent is always part over the whole thing times 100. I'm going to do it down here. So 14 times 2 is 28. So that's the mass of the nitrogen divided by 32 times 100, of course. And we go ahead and plug that into the calculator. And we get an answer of 87.5, which rounds to 88%, which is choice 3. For 38, which ion in the ground state has the same electron configuration as an atom of neon in the ground state? So with neon, the symbol is Ne. We need to get that electron configuration and then figure out what we have for the rest. We have neon and the electron configuration of 2-8. So I'm going to do this right from the table. So calcium is here. That's the first choice, but it's calcium plus 2. So instead of 20 electrons, it would be 2 less. If I move back to element 18, that's argon. So element 18 is not neon. So choice 1, which is calcium, Ca2 plus is not the answer. The next one is chlorine. Chlorine is next to argon. See, Cl minus 1 would again make it the same electron configuration as argon, and we need neon. That's not going to be our answer either. We go to choice 3, which is lithium, right? Plus 1, 2, helium. That's not the answer either. What must it be? It must be oxygen. Oxygen is element 8, but when it gains 2 electrons, it goes to neon, and that is our answer, which is choice 4 for question 38. Moving on. For question 39, we're given 4 compounds. We're given their molar masses and their boiling points, and we're asked to figure out which compound has the strongest intermolecular forces. Now, this is something you might have already memorized, and you don't necessarily need the information in the table to figure it out, that your answer here is going to be choice 1. And the reason why we say that is HF, when you have hydrogen bonded to fluorine, oxygen, or nitrogen, you have what's known as hydrogen bonding, which is the strongest intermolecular forces. The other 3 choices are just dipole attractions because all 4 are polar molecules. Now, the reason for the information is that HF, while it has the lowest molecular mass, you would think the more massive, the higher the boiling point. It actually has the higher boiling point of the 4. You remembered that HF, H2O, and NH3 are the highest or the strongest intermolecular forces as far as molecule to molecule, known as hydrogen bonding. All right, let's go to question 40. For question 40, we have our particle diagrams, and we're asked which of these particle model diagrams represents xenon. Now, xenon is a noble gas, so we're looking for something that's in the gas phase, which is only going to be choices 1 or 2, but it's a noble gas, which means it's monatomic, so individual atoms, as opposed to diatomic, which is choice 2. So the answer is choice 1. Question 41, the amount of heat absorbed when the temperature of 75 grams of water increases from 20 to 35 degrees Celsius. Well, we're dealing with water. We have the mass, we have a delta T or a temperature change, and we're looking for heat. We need a heat equation. That means we're going to the reference table T that is, and you see there are three heat equations. Now, the one that we need is the first one because we're going to have a delta T, and that means that I have water as a liquid, so it's one phase. These last two heat equations are for phase changes. The other thing we need is we need the specific heat capacity for water, and even though you might think you've memorized it because you've done this before, you're going to go now to the front of the reference tables to find that. Table B has the specific heat capacity for water as a liquid, 4.18, and we're going to need that. Always when you're doing a math problem, I would recommend writing the equation down. Q is equal to M C delta T, that's the one we need. We're looking for Q, that's our heat. Our mass is 75 grams. Our C from reference table B, 4.18. And delta T, of course, we have 35 minus 20, which is 15. And now we're going to go ahead and crank this in the calculator and come up with the answer. Now the answer is going to be in joules, and luckily our four choices are in joules. Sometimes, however, be careful. The answer they might be looking for is in kilojoules. Then you would have to divide by 1,000. Not here though. We're going to just multiply this out and find our answer. In the calculator, the answer is 4702. Of course, the closest answer then is choice 2 for 41. Okay, so let's go to 42. Which sample of HCl reacts the fastest rate with 1 gram of sample of iron filings? Well, this is a 2 for 1 because you'll notice that the concentration of HCl is changing and also temperature. So the greater the concentration, the faster the rate. So 3 molar is going to be better than 1 molar. So cross out choices 1 and 2. And then, of course, as far as reaction rates go, the higher the temperature, the more energy, the faster the reaction. So 25 degrees Celsius higher than 10. So our answer for 42 is choice 4. If we go to 43, we're looking at a system at equilibrium. Remember, what's equal at equilibrium is the rate of the forward is equal to the rate of the reverse. As far as concentrations, they would remain constant. That's what we're looking for here in the four choices. So let me go ahead and scroll down. Concentrations must be constant. Rates must be equal. The answer for 43 is choice 4. For question 44, given the equation representing a system in equilibrium, says which change will cause the equilibrium to shift to the right. So we want more products, and how is that going to happen? Well, in choice 1, that's not going to work. Adding a catalyst speeds up the rate of the forward and the reverse. If we add more PCl3 in number 2, whatever side you're adding to, which in this case would be the right side, it would shift to the left. That's not going to be it. Increasing the pressure. If we increase the pressure in number 3, I have 2 moles of gas on the right, 1 mole on the left. It would again shift to the left. The only answer it can be is choice 4. It's going to shift to the right because it's endothermic to the right. For 45, it says we have a formula representing a molecule, and what is the chemical name? Well, look at this. I was going to say 6, but there's actually 5 carbon atoms. You got to go to the organic reference tables. There's 3 tables. The first table is all about the number of carbons and the prefix. The prefix is pent, but we have that in all 4 choices. So the next thing is we need to look at the reference table that gives us the functional groups. The only thing different other than our carbons and hydrogens is nitrogen. So it's either going to be an amine or an amide. It won't be a pentanone, that's with oxygen, or pentanol, that's with oxygen. So let's just go and take a look And sure enough, we'll have our answer. Here is amine and amide at the bottom of the reference table. And take a look, it's got to be an amine, because amides have nitrogen and oxygen. That makes the answer for 45, choice 3. All right, we got 5 more left. Okay, so in question 46, we're given a compound. You see that it's all carbons and hydrogens, so you know it's an organic compound, and we're just asked to classify it. All right, so remember, you have your 3 reference tables for organic, P, Q, R. P is your prefixes, Q is your hydrocarbons, that's alkane, alkene, alkyne, and then R are other functional groups, so other atoms besides carbon and hydrogen on the molecule. Well, since it's just carbons and hydrogens, we need reference table Q, and let's take a look. Now, all you have to do here is pattern recognition. You had a triple bond in that molecule on the test, and that makes it an alkyne. So that's all we were looking for there. It's alkyne, which is choice 3. For 47, we're looking for which equation represents fermentation. Now, for organic reactions, you need to memorize the pattern for organic reactions to know the answer here. But fermentation, we're talking about sugars, and we're making alcohol and carbon dioxide. So that answer here would be choice 3. It's memorization, folks. You got to know your organic reactions. Let's keep going. All right, in 48 here, we're looking for the oxidation number of copper changing from. Well, first of all, as far as oxidation numbers go, when any element is alone, which copper is on the right-hand side, it has a 0 because it's not giving electrons away or taking them. So right away, choices 3 and 4 are out of the box. So now you're left with 1 and 2. Copper and copper 2 chloride, right? I got Cl, that's going to be a -1. Copper is either going to be +1 or +2. In this case, since there's 2 chlorines for every 1 copper, we're talking about +2 to 0. Oxidation numbers are on the reference tables, so you can always take a peek there and at least go with something that's on the table for the element. Let's keep going. We got 2 more. Question 49. We're looking at a reversible reaction, and according to one acid-base theory, the 2 H plus donors are. Well, what they're talking about here is the Bronsted-Lowry theory. An H plus donor means it's starting out as an acid and becoming a base. So if I look at the left, I have acetic acid here, and I have water. Well, here's my acid. That's an H plus donor, so it has to be COOH, and then it's going to be, I'm going to choose from the last 2 here. So I can cross out 3 and 4, and going from right to left, it's got to be the H3O plus that's going to donate the H plus back to CH3COO minus, so that makes choice 2 our answer. All right, and finally for number 50, which nuclear equation represents a spontaneous decay? Spontaneous means it's going to happen on its own. It's going to happen on its own, it's decaying. You're starting with only 1 reactant. So sure enough, 2, 3, and 4 are out of the box. The answer has to be choice 1. More specifically, you're getting 2 protons, 2 neutrons known as a helium nucleus. This is alpha decay. You didn't have to know that. You just had to know it was spontaneous decay, but you have alpha decay, beta decay, and gamma radiation, which is spontaneous, those 3. With 50, that ends B-1. It's on to the short answer questions in B-2. Keep working hard. Good luck.